back. We are in a brand new section, 5-6. We've got a couple theorems to look at. So we're going to add this to our electronic notebook. And the Hinge theorem, let me kind of go through this one. This one has a nice name, so you don't have to remember all these words. Here's what you need to look for when you're studying triangles. Again, we're still delving into triangle relationships, okay? So we're comparing two triangles, and if you see two sides of one triangle are congruent to two sides of another triangle, but the included angles are not congruent, then the longer third side is across from the larger included angle. Now that ties into what we just learned, okay, in the last section. So as you can see from the figure, we've got AB is equal to DE, those lengths, and AC is equal to DF. So there's your two sides that are congruent in one triangle that are congruent with two sides in another triangle. But they're telling you the measure of angle A is bigger than the measure of angle D. You know that angle A is bigger than angle D. So the conclusion is the side opposite of angle A, which is BC, has to be bigger than the side opposite of angle D. That's what that's saying. So that's really important that you're kind of catching on, and when you're looking at two triangles, that you're looking for these relationships, not assuming that they're there, but you're actually seeing that these two sides are congruent, but the included angles are not, okay? That's what you're looking for. Now the converse, okay, says if you've got two sides of one triangle are congruent to two sides of another triangle, and the third sides are not congruent. So GH is bigger than KL, which is what they're showing us here, then you can deduce the opposite, which means whatever angle is opposite of GH, which is the measure of angle J, that angle has to be bigger than angle M, which is opposite of that shorter side. So that's what they're trying to show you there, and hopefully you see that from the drawing, what's going on. So now let's apply Hinge theorem and its converse to a couple of situations. So they want us to compare the measure of angle PQS, which is this angle right here, I'll put a little dot here, and the measure of angle RQS, which is this angle right here, okay? So PQS and RQS. Now, as you're thinking about it, let's look at what we do know, so we can figure out, well, what, are we using the theorem or are we using the converse, okay? So we can clearly see PQ is equal to QR, because both of them are equal to 7. And we know that QS is equal to itself. And then we know that PS is bigger than SR. We can see that. PS is 5.3, 5.3 is bigger than 5.1. So we can see that, okay? They gave us only side lengths, no angle information. They only gave us side lengths. So we're going to use the converse to show a relationship between those two angles that they asked us about. So PQS is the angle that is opposite of PS. So angle PQS is going to be bigger than angle RQS. RQS is the angle that lies opposite of SR. And so because we found that relationship with those third set of sides there, then we were able to determine a relationship with the angle using the converse. So in this one, I would say this is the converse. That's how we proved it, basically. Okay, so let's look at letter B. Compare KL and MN. Okay, so let's figure out what we know. We know that LM is equal to KN because they're both equal to 6. We know that LN is equal to itself. That's reflexive. And then we can see that angle LNK is smaller, less than angle MLN. Okay, so we can see that LNK, which is 53 degrees, is smaller than MLN, which is 57 degrees. So we see a relationship there. You could have written it the opposite. You could have said MLN is bigger than KLN or KNL, okay? So however you wanted to write that, I just started with a smaller angle. You could have started with the larger angle. So now let's look at KL. KL is opposite of that 53 degrees. That's opposite of that LNK. So KL has to be smaller than the side that's opposite of that bigger angle. So MN is opposite of angle MLN. And so that's the relationship we would write here. And so we use the actual theorem. We use the Hinge theorem to help prove that. Because that one says if you have two sets of sides that are congruent, but those included angles are not the same, then whichever one's bigger has the bigger side opposite of it. So that's really why we would use the Hinge theorem there. Okay, letter C, we have multi-step, so we're going to find the range of values for Z. We have angle UVT, as you can see in the figure, and it's got a Z in there, 6Z minus 3. We don't know the actual measure of that, so could be a range of values. So we got to compare the side lengths. We know that UV is equal to VW. Okay, I don't know how long it is. I just can tell from the figure that they are equal. We know that VT is equal to itself because they're reflexive. And we know that UT is smaller than TW. Okay, we can see that because 24 is less than 25. So we can really see that pretty clearly from the figure. So what relationship are we utilizing here? We have information about all three angles, all three sides, but nothing about the angles really. We're going to be using the converse to kind of make some decisions here. The angle that's opposite of UT or TU is that 6Z minus 3. And we know that that's smaller than the angle 45 degrees, which is opposite of that TW. So we'll be able to figure out, we can do some basic algebra here. We're going to add 3, and then we've got to divide by 6 to figure out, what we'll one end of this is that Z has to be a number that's less than 8. Has to be. Okay? Now, since angle UVT is in a triangle, the measure of UVT has to be bigger than 0 degrees. So I hope that makes sense. It can't be 0 degrees. It has to actually be bigger than 0 degrees. So we already know what that measure is. We know that 6Z minus 3 has to be bigger than 0. Has to be. So this is what's going to help us find the other end of that spectrum to figure out, what is the range of possibilities here. Okay, so we've got 6Z is greater than 3, and then we'll divide each side by 6. So Z has to be bigger than 0.5 or 1/2. Okay, so it's got to be bigger than 0.5, but less than 8. Okay, so combine the inequalities together, and here's my range of values. Z can be 0.5 on up to 8, not including 0.5 and 8. Okay, so hopefully that made sense to you, and you were able to kind of pick through that and go, okay, I see how I can do a range of values here. All right, check it out as yours. I'm going to give a point for each, give it your best shot, and set up those inequalities and see what you do with that. All right, good luck, and bring your questions to class.